Give me 10 minutes of your time and I will change your perspective on binary search completely. I will teach you a technique that is going to impact how you see binary search, how you solve binary search. So let's get started. So the general way of thinking binary search is that if I can sort the array, then I can apply binary search. So let's say this is the input array that you have. Now we need to sort the array to apply the binary search. Now this array is already sorted, so we can apply binary search. If I apply binary search on 2, we saw earlier that it can return any index 1, 2 or 3. That depends upon the implementation. After that we saw lower bound and upper bound that can target the very first occurrence or the very last occurrence. By using the exact same approach that we use for lower bound and upper bound, we are going to convert this input array into another array where the value will be changed only once. It will be 0 and it will be 1. The value will be changed only once in the entire array. The very first encounter of 1 is going to be the answer that we want. So I need to change the input array into the array that I want, array with zeros and 1, in such a way that the very first occurrence of 1 will be the answer. Once we go through the example, it will become more clearer to you. Okay, so let's see how it's going to impact our searching technique. So let's say we want to search the element 5. What we used to do, we used to divide the array into two sections. Based on the middle element, we used to divide the array into two sections, that is left and right. And this is our middle element. Now we used to check the value of middle element with the value that we want to search. Now if this value, the middle element value, is greater than the value that we want to search, then we used to find the answer in left portion, right? That's what we used to do in traditional binary search. But now we are changing our way of thinking. We are going to convert this array into another array with zeros and 1. Very first encounter of 1 will be at the exact position where our answer is. So we want to find the value 5, correct? So I am going to define a function f of x where x is the index, and the function definition goes something like this. Array of x, that is the element present at xth index, should be greater than or equal to 5. Then I will assign it as 1, otherwise it will be 0. Let's look at the example that we have here. 1 is less than 5, so it will be 0. 2 is less than 5, so it will be 0. Again, same thing. Now 5 is greater than or equal to 5, so it will be 1. 17 is greater than or equal to 5, so it will be 1. Now I managed to define a function f of x that converted our input array into the array that we want. The very first occurrence of 1 is going to be the index where our value will be. Now I will apply binary search on this and I will find the very first occurrence of 1. That will result me the index 4. And index 4 is the answer, right? So this is the impact our new technique is going to create on our searching method. Now let's say they are asking us to find the upper bound for element 2. Answer will be index 4, right? Upper bound is greater than 2. The very first index where value is strictly greater than 2. So again we are going to define f of x. By using this f of x, we are going to convert our input array into the array that we want. So f of x is going to be element at x position which is strictly greater than target element. This is our f of x. 1 is not greater than 2, so it will be 0. Same thing goes for 2 as well. See, the value should be strictly greater than our target element. Our target element is 2. That's why all these are mapped to 0. Correct? 5 will be mapped to 1. 17 will be mapped to 1. Now again, I will apply binary search on this array. I will find the very first index where the value of 1 exists. That is going to be index 4. And index 4 is going to be my answer. Okay, what about lower bound? See, lower bound by definition means that the index where we have the very first encounter of element which is greater than or equal to our target element. Correct? Here target element is 2. So what is the very first encounter where we have an element which is greater than or equal to 2? Where it is index 1, correct? So I am going to define f of x such that array of x is greater than or equal to target element. So 1 will be mapped to 0 2 will be mapped to 1, 2 will be mapped to 1, likewise, right? Now if I apply binary search on this array and find the very first occurrence of 1, that will give me index 1, and that's my answer. So what exactly we managed to achieve by this new technique? See, earlier our thinking process was, if I can sort the array, I can apply the binary search. But now we are going to change our thinking process. If I can define a function which changes value only once, then I can apply the binary search. I am going to give you an example in an upcoming video where you can clearly see we can find the answer without sorting the input array if we just update our thinking process to defining a function which changes value only once. So these are the new steps that we have to apply binary search. First, we think of a function. Can we define a function which changes value only once? That means all the left values will be 0. Then we will have 1. The very first encounter of 1 will be my final answer. After that, once we found the function, we are going to write a divide and conquer code. Same as binary search style. We are going to use high and low, similarly binary search, to control where actually we are going to search. To control our start and to control our end. We are not going to trim the array or split the array. We are not going to do anything like that. It consumes extra time. We are just going to use 2 pointers high and low to fix our search space. Let's look at our traditional binary search and how we are going to change the code. So this is our traditional binary search, right? First we find the mid. Simple. After that we check whether our mid is equal to our search element. If true, then we return the value of mid. If not, then we have two different possibilities. We have left portion and we have right portion. Either we are going to search the value into right portion or we are going to search the value into left portion. We decide this by using our mid value. If mid value is greater than search element, that means we need to search the value into left side. Otherwise we will search the value into right side. Simple, right? And we are controlling everything by using this left and right pointers. You can call them low and high as well, no worries. Or you can call them left and right. So this is our traditional binary search. But now we are going to change our mindset and we are going to start using the new technique that we just saw. So again, in new technique also, we compute the value of mid. Okay, no problem. Then we invoke our function f by passing the mid value and the target element that we have. If it returns the value 1, that means this could be the potential answer. Remember, our function f of x is going to transform our input array such that initially we will have 0, at some point we start to get 1. Imagine this being a mid. Value here is 1, no problem. On the right hand side, we will definitely have 1 because that's how we are going to define our function. But it might be the case that I might encounter 1 to the left side of this. That's why we need to search on the left side. And what is the answer that we want? The very first index where we have 1. That's going to be the answer. So we cannot just stop here. We need to search to the left of it. And that's what we are doing here. Even though we found the value 1, we still search to the left side. That's why we are updating the high pointer. So this code is fixed. This code is divide and conquer code with proper f function. Now by changing the implementation of our f function, we can define what this answer is going to be. For example, let's say I'm going to define my f function in such a way that it's going to search the value. So I'm just going to define it as array of x greater than or equal to 5. So what it will do, it will ultimately search the very first index which is greater than or equal to 5. Correct? If 5 exists, it's going to be binary search. If 5 does not exist, then it's going to be lower bound. For upper bound, what I am going to do, I am going to define in this way. We have already seen why this works, right? See, this is the definition. We need to find the very first index where we have value strictly greater than our target element. So you will have 0, 0, 0 and at some point you will have 1. After that you will start getting ones only because that is in sorted order. Correct? Now the very first index where you have 1, that is going to be the answer for the upper bound. And that's what we have defined here. Same thing goes for the lower bound as well. Right? We are going to define f of x such that array of x is greater than or equal to our target element. Now we don't have to ask whether we have to sort the input array or not. Rather than asking can I sort the input array, we are now going to ask can I define a function which changes the value only once. And if I can define the function that changes the value only once, that means I can apply the binary search in one way or the other.